Hello, in this video, we're going to be talking about types of three-dimensional figures. We're going to classify solids. Solids is another word for three-dimensional figures. We're going to describe cross-sections of those figures, and we're going to be able to sketch and describe what we call solids of revolution. So first, a little bit of vocabulary. In a three-dimensional figure, you have something called a polyhedron. A polyhedron is a three-dimensional figure where every single face of the figure, the face is the flat part, every single face is completely flat, every single edge is completely straight, and that makes it a polyhedron. Okay, where two or more edges meet, you call that a vertex. Okay, so these are some examples of what we call polyhedra. That's the plural of polyhedron. So this, you'll see it has all flat faces. We could call this like a box, but really we would call it a prism. This down here, you'll see that we have flat faces on the sides and then a flat bottom. The top comes to a point. That is what we call pyramid. Over here, these are going to be examples that are not polyhedra. Okay? Cylinder is not a polyhedra because this face of the cylinder, where a label would be on a soup can, for example, that is rounded, that's curved, right? This cone, which is kind of like a cylinder in that it's circular shaped on one side, but it comes to a point at the top that also has round parts going on, right? It's curved. And here we have a sphere. There are no edges on a sphere. There are no vertices on a sphere. It's just the whole entire thing is round, and this is also not a polyhedron. So let's classify these solids right here. We have, in this first figure, we have a solid that has 1, 2, 3, 4, 5, and 6 if we count around the back. So the bottom of this is going to be a hexagon. And then we see that it has straight faces going up. So yes, it is a polyhedron. And it goes all the way up and meets at a point, right? So we would call this a hexagonal pyramid. And yes, it is a polyhedron. Okay. Here, this next figure, we have this flat face on the top. Okay. We have this flat face on the side, and this looks like it's a semicircle. Maybe it's a semicircle with a rectangle kind of joined together. Okay. But then because this edge down on the bottom, because this edge down here is curved, we're going to say this is not a polyhedron. Okay. In our last example over here, we have a flat face right here that's in the shape of a triangle. It's a flat bottom, a flat side, a flat slant right here, and then a flat back to it. So, and every single edge is perfectly straight. Because this is a triangle, then we have that repeated as triangle in the back side right here. We're going to call this, yes, it's a polyhedron. This kind of polyhedron is called a triangular prism. Prism because all of the sides are straight and the top is the same as the bottom. Okay, now let's talk about something that we call cross sections. A cross section is a section, like a very, very paper thin slice of a figure, right? It could be a polyhedron, it could be a sphere, it could be a cone. It doesn't have to be um, exactly a polyhedron. It's any type of three-dimensional figure. It is a completely flat, two-dimensional cross section. Okay, if we have this figure right here, this is a cube where all of the edges are the same length all the way around, right? We take a cross section in here. That cross section is going to be a square, okay, where all of the angles are right angles and all of the sides are congruent. Okay, if we take that same cube and instead we take a cross section going diagonally from one edge through the figure to another edge right here, that's going to create a rectangle. Okay, it's going to create these two edges right here that are parallel, right? And it's going to create this edge and this edge in the back that are parallel to each other, but they're longer than the first two sides. So you can see that this would make a rectangle as opposed to a square. Okay, then this last one over here, we take the cross section of this little corner, if you will, of the cube. We've got in the front, we've got an edge. In the back, we've got an edge. And then down on the bottom, we've got another edge, and that's going to create a triangle. And you can angle this triangle however you want to angle it. And it might be an equilateral triangle. It might be an isosceles triangle with only two sides the same. It might be a scalene triangle where all three sides are different. Okay, so let's examine cross sections of these figures. Right? This right here, we have a hexagon in the front, a hexagon in the back, and we are taking a cross section in the middle. So that cross section is going to be a hexagon. Okay. Here we have a triangular bottom coming to a point at one side, right? So this is actually going to be a triangular pyramid. And here we have a cross section, and that cross section is just going to be a triangle. Okay. Here we have Here we have a cylinder, round on the top, round on the bottom, nice straight sides, but we're taking a cross section down in the back here, and that's going to be a straight side. Down along the bottom, that's going to be another straight piece. Here on the side, that's going to be a straight piece. And along the top, and that's going to be another straight piece. So now you can see that this cross section is actually a rectangle. Okay. Here we have cone. We've got a circular bottom coming to a peak at the top, and we're taking a cross section. Now I can't tell if this cross section is supposed to be parallel to the bottom face or if it's supposed to be at an angle. If it's supposed to be parallel to the bottom face, then we're just going to have a circle, a nice round symmetric circle. Okay. If it is not parallel to the bottom face, then it's actually going to be an oval, where you would have part of it longer than the other part, okay? Here we've got, for E, we've got a sphere, and this dot in the center indicates that this